Hello, I'm Doug Parody, and I want to show you my entry to the Sparkfun AVC 2015 contest being held up in Colorado this June 20th. The name of the robot is Bouncer 2, and I am our team member of Dallas Personal Robotics Group. We're real excited about the 2015 AVC contest. This is the first year we've attempted to enter it, and we're going to have 5 members and 2 robots at the contest. We're taking a couple of approaches. This robot is supposed to attack the course without using GPS, so it's a little bit different. Our other robot, which is being fielded by member Dick Swan, is more traditional for this contest. It's a Pickhock version, autopilot based robot. So on this one, let's go down through it and kind of talk about some of the features. First, the chassis is a Quantum Vandal XL RC chassis, which is a 1/10 scale 4-wheel drive chassis. On that, we've added 2 decks and a mast. The decks, on the first deck we have a Arduino Mega, which is acting as the servo controller and sort of our serial port communicator. We also have a UBEC on that particular platform, which provides all the 5-volt and 3.3-volt power. We've learned a few things building robots, and one of the things that we've learned is that you always want to have a switch on the top and you always want to have a display. And so again, on the switch, all the power wiring is wired through a double pole, double throw, heavy duty switch to handle current. And we have an on-off switch on the top that makes it simple. We also have one of the LCD keypad shields, which has got a 16:2 LCD plus an array of buttons, and that's what we wanted to use for the interface on this guy. We also have up on the top a board for our digitizing our encoders, or some of our encoders, and we also have a Pixie Cam, and on the Pixie Cam we have a polarized filter to allow it to work on outdoors. The Pixie Cam information is fed into another Arduino Pro Mini, which reduces that information into pertinent data that's fed by UART to the other processors. On top of the mass, we have an ST nuclear board, which is their F0401 board, plus their add-on, ST's add-on IMU. We are using their licensed IMU technology to provide a heading. Since we don't have the ability to do major changes in that, we're data fusing the encoder data outside of the head, so it's providing a heading, and we're data fusing the encoder information. Currently, the robot has 3 encoders. It has a shaft encoder in the back, which runs off of the drive shaft, and all of these are quadrature. We also have on both front wheels a quadrature encoder with a quadrature encoder disc in the back. That's a black disc has been provided into the wheel, and then an encoder disc has been done on it. Now, We were attempting to have all 5 wheels with encoders, and with the intent that the information between the shaft encoder, which would give us the speed of the motor, and the differences in expected speed from the rear and front to provide other bits of information. But we took a slightly different approach on that, which probably will not work. It's workable, but we're not probably going to have it completely debugged by the contest. And in this one we used a squirrel cage encoder disc, and we used one of the easy to obtain encoder, quadrature encoders that you can either get from Pololu or DF Robot. So that eventually will be worked out, and will maybe be a little more all-weather, but right now this encoder is working without any issues, and so we'll probably pursue that. Now let's see. From a software point of view, the ST microcontroller is providing the heading information and also handling the interrupts for the encoders. It's going to be set up for 5 encoders, so we'll only be using 3. The data fusion will also occur up here, and it will essentially provide down to the Arduino simply the speed and angle that the steering and motor should be taking. We have a bumper for emergency stops, a sonar, which will provide us about a 24 to 36 early warning so that the robot could deaccelerate if all goes well. If not, you hit it with the bumper and turn the motor off. The software that we have for the Pixie has all been completed. We've used that in other robots and for different contests. We also have, since we're using Arduino, the interface for the pad is pretty much done through their libraries, and also the Mega is taking advantage of the servo library and a few other things. So it's not completely being done by scratch from us. We're powering it with a hard case lithium. It's a 2-cell 7.4 volt 4,000 milliamp hour battery, and we also have, depending on the course, and Dick, our other team member, actually lives in Colorado and probably will provide us some course information, and we may use a lidar light if we can find features that we think can utilize it, but that may not happen. All right, that's about it. I can't wait to get up there. We're 2 weeks away. It's exciting. So, bye.